Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. This week, we had some updates to stories we covered last week, some binary exploits, including an iOS RCE that was published by Project Zero, as well as some research with defending against Linux kernel use after freeze, and using Alexa to snoop on your mobile activities. So before that, though, I will quickly mention we are going on a break after next week, the 14th. We're going on a break for 2 weeks until the 4th of January in the new year. Now that that's out of the way, we'll jump into some of our news. So Google put out a blog post today about the Google Summer Internship Program. It seems like it's a recap of the projects that were covered this year, and I think we might have talked about some of them already when we covered the Google Summer of Code before.
Yeah, well, I feel like we've definitely talked about some of the fuzzing stuff before. We talked about what some of the interns were doing. So I saw the update, figure it's another chance to kind of call out, because I do like what Google's doing with their internship program here and kind of offering some of those interns for, the vulnerability research, for fuzzing research and things like that.
Yeah, so they touch on some cool things in this blog post. Mainly just like I said, a recap of some of the work that's been done. That work including porting new targets to OSS fuzz, as well as developing whole new fuzzers for complex targets like Nginx and Postgres. They also investigated using callee, which is a symbolic virtual machine for fuzzing. Have you ever looked at callee, Z? Because I've definitely seen it mentioned quite a few times in some of the circles that I'm in.
Um, Sorry, I was having mic problems. Have we not? I'm pretty sure we've covered it before on episode, or at least
That's what I'm
talked about it
thinking too.
before.
I can't remember if we did or not. Thank you for the tier 1 sub, by the way, Baliga. Thank you. Yeah, I feel like we might have talked about it before, but for some reason, my dumb brain can't remember exactly when
No,
we did
I'm
cover
I'm
it.
looking. I don't see any episode where I have it in my notes, so I might be mistaken about that.
Yeah, I might be getting it confused from when I talked about it with some other people, because it does look kind of promising for fuzzing.
We have talked about some symbolic fuzzers before, or at least those that use it. I think we've covered it mostly in the context of hybrid execution.
Yeah, yeah, we definitely covered that a while ago. But yeah, it looks promising to use in fuzzing. They do state though that is a ways away. There's many issues that have to be worked through there. And then some of the other things were like improving VS Code security. Um, there was also work done on providing sandboxing for some popular open source libraries, like I think like libtiff and stuff like. Um, but there's a lot of other stuff in here too. We won't cover it all, obviously. But if you want to see what some of the interns were up to during the summer at Google, there's a blog post for you, and it might even give you some ideas of what you might want to look at or potentially utilize in whatever you're doing. So yeah, just wanted to quickly mention that. We have an update to the story last week. Last week we talked about how a big CFAA case was being argued on the same day as the podcast, actually. So it wasn't, we didn't have, I don't think it was argued until after we'd finished the podcast. So this was the Van Buren versus United States suit. Quick summary: it was a police officer that abused his position to access license plate information and private information and used it outside of the professional environment. He sold that information to an FBI informant. So mostly this article recaps what went on and some of the arguments that were made in the case, mostly from the justice's angle. I'm
Well,
not
I
going to
mean,
cover
it's.
everything, but I think it can be summed up in one quote. That said, you were going to say something, Z?
I was just going to say, I think the justice's opinion here is really the only one that matters. Although I'm curious
Exactly.
what your summary quote is. So
I would say the key quote for me was Justice Samuel Alito, who said, "This is a very difficult case to decide. I really don't know what those statutes are." Like, what it seems like when I read through this was um, people are scared of the implications of how this case could go, and nobody really knows how this should be interpreted. So
okay,
that's like
see,
the summary quote for me.
when I was going through on this, I actually got the sense here that the justices were generally on the side of the more narrow interpretation. And you kind of had two trains of thought on that. On the more liberal, from the few liberal justices left on there, Kagan and Sotomayor, I'm not exactly sure on the pronunciation there. Both kind of were critical of the government's intention with that, like just pushing it. And then kind of the more conservative side was taking a bit more of a concern with the government overreaching. So one was kind of more of a moral base, and the other was government overreach. But because of that, you kind of have the majority, it seems like, are kind of leaning towards the more restrictive definition. Again, I'm not a lawyer, so I can't give a lot of comment on the actual legal aspects, but I did get the sense here that we're probably going to get a more narrow reading or a more narrow judgment on the basis of this. It seemed like most of the comments were critical of the government pushing this, rather than of Van Buren and his lawyer pushing that he was authorized to access, but just misused it. Like you did say, there is the case of, or at least a lot of this came back down to the fact that, yes, I mean, what Van Buren did wasn't acceptable for a police officer to do, but it shouldn't be the CFAA that punishes it. There are other statutes that make his actions illegal, or that he can be punished for, or punished using.
Yeah, so the defense that was made against the CFAA and the government by the Van Buren's lawyer was basically the fact that the statute doesn't criminalize obtaining information that the defendant had the right to obtain. And there's some pedantic argumentation going on there too.
Well, so the
Basically
pedantic
coming down to the
argument,
statement that he's not entitled so to obtain, focusing on that so word there.
yeah,
What were you gonna say?
that was the government's argument. The opposing argument was focused on the definition of the word "so," or not the definition of the usage of the word "so" and how it applies, and that's where we saw two of the more liberal judges commenting on how that's being interpreted, whereas the comments that we tend to get from like Gorsuch and Kavanaugh were more focused on um the other laws that could be used. At least that's where the comments came. Obviously, we're only basing our understanding on what SCOTUS blog is saying.
Yeah. And one of the arguments I found interesting from the justice I mentioned earlier was he quotes, many government employees are given access to all sorts of personal information, but if they use that for personal purposes to make money or carry out or protect criminal activity, they can do enormous damage. And it's showing how that's kind of why they have the problem with the government using the CFAA in this case, is because if the defense can successfully counter it, it opens up like a whole can of worms when it comes to um, like government employees and stuff like that. But yeah, I was kind of reading through this and thinking the same thing. Like, it seems really stupid to charge him under the CFAA. Um, like, surely there were other charges that would be like so much easier to stick, and that's kind of what the justices were getting at there. They said like, why are we here again on or a rather small state crime that is prosecutable under state law or other federal laws? It seemed like they were kind of annoyed that they even had to like deal with this case.
Yeah, it seems like because he was charged with some other things. We brought that up during the last episode, and those got dropped. And the CFAA one was the one remaining. I'm not sure why they got dropped. If it was just part of like a plea that they would drop those charges and only leave them going for the CFAA case, or if it was something like that that kind of led to it. But there definitely were other charges raised, including, I believe, a corruption charge, which seems to make a lot more sense in this case. Abusing his power, getting paid for it.
So do you have like a positive view of this of what the justices' opinions are here regarding CFAA, or do you think they're off the mark? It seems like you kind of agree with them
Well,
more
I'm
than
definitely hoping
against
for
them.
the more narrow interpretation here. So, as it seems like that's the direction the justices are going, I'm kind of happy with that.
Okay. I mean, my main takeaway from this was just that
Yeah,
the CFAA seems to be a mess.
They do mention here that's always a risk to put too much weight on discussion at an argument, kind of towards the end of this article, which is fair. But they do mention how there's kind of the dual problem of, or the dual problem the government faces here is a core group of justices who appear to think prosecution is fundamentally wrong-headed. Um, and overlapping is another group of justices who think the language is far too vague to justify the broad reach of the government. So that summarizes the two groups that I was trying to mention earlier. But yeah, I mean, I'm hoping that we get a more narrow definition out of this. We talked about this a lot last episode. I don't think I need to restate everything, but like there are implications for security research if you can so easily end up in the wrong, even when you're acting in good faith. And there's been so much progress over the last like 20 years from, vulnerability reporting being like, just don't do it because you can get charged for it to now there's, all these bug bounties and it's a lot more open now. So it would be nice to kind of see the law come along with that.
Yeah, I'd agree. Like you said, though, I think if you want to hear some of our discussion around that, go back to the last episode because we don't want to retread all the same ground. So yeah, you can watch that episode if you missed some of our discussion on that part. So Z, you have an update when it comes to the Snapchat SSRF we briefly touched on last week.
Yeah, as you said, we touched on this last week. Snapchat had an SSRF. This was found by NomSec and some others. And I believe they actually talked about it on a stream like right before we started our stream. This dropped just before. And I had mentioned what was interesting here was the fact that they were using DNS rebinding to access the internal web endpoints, which is interesting one since I thought they were using that to get around mitigation that was in place. What it turns out is happening here actually is they end up using the DNS rebinding to get around the same origin policy so they can add custom headers when they're making requests to those internal IPs. That allows them to add one of the headers, the ex-Google metadata request header, which gives you full access kind of to the metadata API. So I just wanted to call it that little aspect because that is, I think, a unique and interesting aspect of this issue in terms of how they exploited it that we just completely missed last week.
All right. So we'll kick off our exploit segment with a remote code execution as system through 3D printer management software. So this is Repetier Server. So they started off by discovering the application had a feature that allowed calling external commands. So the rest of the process and the blog post is basically around how do I access that feature. So it's kind of a sync to source methodology going on here. I found a dangerous functionality. How do I reach it? So they ended up finding 4 bugs, 3 of which were chained for the remote code execution. The first bug isn't super impactful or interesting. It's mostly just an arbitrary content issue where you can upload a watermark and they check the extension on it, I think, but they don't check the content. So you can use another endpoint to read that data back. So since they don't check the content, you can use it as kind of a side channel, which is what it's used for later on. The second issue is another file upload related issue, though more interesting this time. When creating a printer, a configuration file gets created and a directory gets created with more assets and whatnot. And there's a directory traversal in the printer name, which can allow you to write to file locations outside of the intended path. In this case, they were able to use it to write to the file location used for loading external commands, though they couldn't fully control the contents. And that's where the third issue comes into play, which is yet another file upload related issue, but kind of the reverse situation of the second issue. With the last issue, you could control the path to some degree, but not the contents. This one, you can control the contents partially, but not the path. And this was through the replace printer configuration feature, which, as the name implies, it allowed you to update the printer configuration. It does do some checking on that config you upload to check if it's valid, but the author found that those checks weren't really sufficient. They don't really go into details, but it seems you can just put whatever you need in there and then add whatever you want on top. They don't validate everything. And that allows them to replace the configuration file set up with the second issue to execute arbitrary commands. Now, what's worth noting is this issue does require the user to reboot to exploit the issue. I believe it's because the external commands are only executed on initialization, and they couldn't find an issue to trigger that restart, so they kind of just have to hope and wait for the user to manually restart. Um, so
Which
the
for
first,
something like this can definitely take a little while.
yeah,
Um, I do want to comment here. So the external command seems just like a convenience feature where it's like even in their description when they're talking about it, they show a screenshot from the documents where it's like, sometimes it's convenient to run shell commands without needing to open a shell. Um, one of their examples is the shutdown now thing. I mean, like, it's fair, but this just feels like an unnecessary feature, especially like for shutdown. Like, that seems like something they could just offer and not offer this really dynamic functionality. It's just this whole feature just adds a ton of attack surface in general. The other thing I want to bring up is they use this first bug, that watermark file, as how they exfil. So they write a external command that will write to the watermark file, which they can then download. It feels a little bit weird to be calling, like, I get why the watermark, like why uploading that without actually having a file can maybe be a bug. But like there should be like even a static file directory in this application that they could also write to have their output visible. It doesn't feel like that should be necessary. Maybe it is, but I would have liked them to actually indicate why they need to go that route versus something more obvious, like just writing a file into the web root.
yeah,
So the lack there was just stands out as a little bit weird to me. Sorry, go ahead.
Yeah, I found that first issue and how they used it really interesting personally. Not only was it used as a medium for getting the output from commands ran, as you mentioned, they also used it to store commands to execute. So they'll run a command that'll copy the watermark file into a batch file, execute the batch file, and then pipe the output back to the watermark, and then they delete the batch file. So near the bottom of the post, they actually have a nice little diagram that shows the kind of exploit flow. Um, there was also a bonus section where what they used to confirm exploitation of the previous issue. They had a remote file system enumeration through the global settings folder menu for selecting a root folder for the printer. This doesn't really seem to be a bug. I think it's just more of an intended feature that's being abused, which is probably why I don't think a CVE was issued for this bonus issue or the first, the watermark thing, because they put out a fix for the directory traversal and insufficient configuration validation. Um, they probably should check the contents with the first issue to make sure that the watermark is actually like an image or a uh, valid file contents and not just whatever you want in there. I guess they just don't really care enough.
So what they should do is add authentication as default. That should be the fix here, not running everything without authentication. So authentication is a feature. That is something I went and actually looked at this application just to go see, like, are they hiding authentication behind a like paywall like we've seen some other products do? And no, like it is part of the default. It's just or it is part of the default install, but it's not enabled by default. So this kind of comes back to that issue I've hit on before is security shouldn't, or you should be secure by default. It shouldn't be something you need to add on. So they say, oh, they don't include authentication enabled by default because they want it to be as convenient as possible. Just let them enter a username and password on first access. I'm sure that could be abused, like we talked about with the Ubuntu issue before, where they happen to find like some edge case and issue there. But generally speaking, if they just did that, it's not going to be all that difficult to use on that first setup, and the security is going to be there by default.
Insecure defaults coming in clutch again. So the vulnerabilities themselves here, I don't think were super interesting. I did kind of like how they were chained together, though, especially like I said with that first issue, because it seems like an issue that's not very useful at first and doesn't really have any impact. But it does come into play later on. Like you said, though, I do wish there was a little bit more information on why they went that route and not an easier route. But yeah, obviously we can wish all we want, but they're probably not going to update the blog post just because of that. All right. So Whitcoat put out a site-wide CSRF on Glassdoor. So Glassdoor, for those of you who haven't ever used it, it's a site that's commonly used for job searching. Not only does it have job search and listing capability for employers, it also has salaries and reviews for different companies that you can leave and positions. I've used it a few times for that actually, getting some information on salary information for a particular position at a company. The issue here is how they do validation of CSRF tokens. They do try to prevent CSRF on all their endpoints. It just the tokens weren't sufficiently validated. The problem was if you passed a token that followed the expected format, but you didn't give it the number of characters it expected, because of a logic issue, it would treat the token as if it were valid, even if it wasn't. And this token would be accepted for both job seekers and employers, so it hit both sides of that.
Yeah, I do want to touch on that a little bit there. With the check, what happened is an unhandled exception would come up. So it would first check the token to see, is this of the valid form? These tokens, for those of you watching, can see that there's kind of these three sections there, separated by colons. I'm trying to highlight that on stream there. You can kind of see the different sections going in there. Just look for the colons, but three sections separated by colons. We don't know what exactly those are stating, but it's three pieces of information. So it would validate that, hey, does it have three pieces of information in it, or the two colons? Yes, it does. So then it would go on to the second one, actually trying to validate whether, like, the session that this token's supposed to be attached to. And when it didn't have enough characters for that, that's where you get this unhandled exception coming on. And because it's unhandled, it just kind of carried on without actually dealing with it, and that's where it just got treated as a success, even though it wasn't actually validated due to that early return.
Yeah. So they were awarded a $3,000 bounty, which is the max bounty for Glassdoor. That makes sense because this was an issue that was site-wide. The fact that it could be used to hit employers too is pretty impactful. In terms of the attack, this is probably the most interesting CSRF for me that we've covered. I don't think we've covered a CSRF that's occurred due to like bad exception handling or something that like I guess low level.
This one, yeah, this one's kind of interesting. I like kind of the way they found this really ended up being kind of accidental. They provide the example at the top of one of the tokens. But when they went to copy it for one of the other tokens, it started with an underscore. So when they copied it, now if you like double click for some copies, it might grab the colon, might not, but underscores sometimes in some applications, it's just not going to get copied. It's going to stop there. I think Sublime does that. I don't remember if it's Sublime. I know there's one app that does that because I've had issues copying constants on it. Or even just overlooking it, but they just dropped one character from the token. And when they tried that on another account, suddenly it just worked. When they were expecting it to fail. So just kind of that accidental discovery of a really somewhat subtle issue, because again, this does work with the normal case.
Yeah, this is kind of an interesting bug class that we don't really see often. So I think this was kind of a cool shakeup. Obviously, the CSRF, we see lots of CSRFs, but I mean like the unhandled exception. Those are fun to see. I like those more subtle logic bugs.
Yeah, we often have cases where it's like, there's CSRF, there's either it has no protection whatsoever, or it's not protecting some endpoint that they were able to abuse. Whereas in this case, it has protection, it's just improper validation. So yeah, it is kind of a more unique case.
So visiting an old friend, GitLab, we have a Stored-XSS that was reported on HackerOne. This is an issue in the error message display for validation of build dependencies, which is used for continuous integration. This one, unlike the last issue, is a little bit more boring. It's a straight up XSS. You can just inject HTML into an invalid YAML file, like an invalid configuration in a YAML file to trigger the error. And those details are stored in the details of the job in the dashboard. So this issue is only present in self-hosted installations of GitLab. It doesn't affect GitLab.com because they disable dependency validation. Still, though, this was treated as a high impact issue. He got a $3,000 bounty. Um, I will say I'm surprised it was rated as a high impact issue. Not only does this only affect self hosted instances, you would need a high level of access to perform this attack. You would need the ability to control YAML files that are used for continuous integration in the repo. Now, I think it's
That
still
does
an issue.
mean you have access, though, to the repo, which isn't that big of an ask, especially if you're running a GitLab instance. You probably have people who have access to the repos that are run on it. So it's not that, like, that is kind of a core, that level of access is a core part of what GitLab is used for. So I think that kind of lowers the bar of getting that level of access. And it's just something like, it's a straightforward access that just shouldn't be there, regardless of the level of privileges. But it is kind of a standard level of privilege, I think, for a GitLab user to have access to edit a file inside of a repo.
For sure, it is
Um,
absolutely an issue. Because it can allow you to perform actions on behalf of the owner if you use this to hit them.
yeah, depending on who views it.
Yeah,
It is, in a sense, like you're compromising users of a repo that you yourself are a user of and have access to. So there is that limitation on, like, it is a bit of a high ask, but it is a very straightforward issue.
so the fix was a little bit slow compared to what we've seen in the past from GitLab. This issue was reported in August, and it was fixed in the beginning of November. So a little bit of a slow turnaround time. That being said, part of the reason for that might have been that key fact that it didn't affect GitLab.com. If it did, this probably would have been fixed a lot quicker. But I just found that interesting because GitLab is usually pretty quick on their turnarounds from what I remember from like past issues we've covered with them. So um, I found it a bit interesting. This one was a bit slower, but
Yeah, I think those RCs we've talked about before, we had the chain of three, I think, in one episode, were handled reasonably quickly. So yeah, I think you're right with the comment that because it didn't impact the actual primary GitLab website, that's probably where they let it slide a little bit or deprioritize it, especially over the summer where more people are taking time off and not really wanting to get back into it, although still a bit long.
mhm. So we have PlayStation stuff again. We have a PlayStation Now app remote code execution through Electron. So PlayStation Now is a cloud gaming subscription service for those of you who aren't uh, MLG gamers out there. But some of you who really love like PS2 games and PS3 games might be familiar with it because it allowed you to play those types of games on like PS4, for example, if it was provided by the service. This involves three issues that are chained together. Though these issues seem to affect the PC client specifically, it might affect the PS4 client, but I'm not totally sure on that. So the first issue is the WebSocket server doesn't check the origin of incoming requests, and that's because WebSockets are not bound by same origin policy, which actually I didn't know. Which is probably why this is an issue. The devs probably didn't know that either. The second issue is that you can tell the Electron application, named AGL. I don't know if I don't think they ever specify what AGL stands for, but I might be wrong. Might have missed it. But basically, they use that application, and it can load any website or application through the set URL default browser command. And the third issue is that AGL application has node integration set to true instead of false. And if you've listened to our podcast in the last few episodes, specifically episode 49, or if you do AppSec when it comes to Electron-based applications, you'll know why this is a bad thing. You can invoke native Node.js functions with JavaScript code, which can allow you to do things like file system writes and system command execution. The list goes on. That you kind of have like Turing complete capability at that point.
Well,
Um,
you have, yeah, complete code execution at that point with access like to everything inside of the node environment.
yeah. So this is especially problematic because of that second issue. You can make it load any website, so you don't even need like an XSS or anything to exploit this issue. So on their own, these are some pretty serious issues. Chained together, it's pretty catastrophic security wise, which is probably why this chain ended up getting a 9.6 critical rating. They also noted the application listened on 0.0.0.0 instead of localhost. So it's not isolated to the local network. Anyone with access to that port, in theory, can send commands to it. So seems like there's quite a few security failures that were
Yeah, I
highlighted
mean,
here.
on like a standard user machine, it's probably going to be running this. The router probably isn't going to let through just the random request on what port was that? 1235. Yeah. Probably isn't going to land. So like there is some protection there. Still should be listening on localhost, not quad zero, but the impact there is a little bit limited because most users aren't exposing their entire computer and everything running it to the internet.
Taking a question out of chat from Balika, does Electron even work on PS4? I'm not totally certain. It could be the case that they bundle Electron with the application and like a compiled form or something. I've never looked at PlayStation Now in terms of like the PlayStation application. So that could be fun to look at. Maybe this could be used on PS4, but I
I
kind of have
don't
my doubts.
Yeah, I would have some significant doubts on having any sort of ready Electron interface. I mean, I guess they could run it as like a website without any of the Chrome around it. As a possibility, I assume you can still run the Electron or like the underlying web applications, but having the Electron access,
Yeah, I don't think so.
yeah, I can't imagine.
So this did lead to a pretty awesome bounty payout. They ended up getting $15,000 for this report. Overall, probably the most impactful attack we've seen in a while. These were some good finds. All right,
Yeah, I
so
mean, there's definitely an impact there. I'm not sure how wide the use of PlayStation Now, like the desktop application, really was.
especially the desktop application, that is a fair point. Because a lot of people use this to play like PS2 and PS3 games on PS4. I haven't heard of anyone actually who uses it on the PC. That being said, I imagine there are some users out there, but it's probably not a super big user base. So yeah, that's a good stipulation to throw on the end there. So it seems there was a bit of a funny story around Microsoft Teams RCE. So there was a report sent to Microsoft about Microsoft Teams, which included multiple an RCE involving multiple bugs. I believe it was a stored-XSS, which could allow you to bypass AngularJS expression injection
Well,
and
so
escape the sandboxing.
so the cross-site scripting itself was just in the message, basically your display name, or in the little message, it would send a JSON object that included information like your display name. The display name itself, you could include Angular um, templates within it or expressions within it. It did do some scanning for Angular expression, so you're not supposed to be able to inject anything like that. But including a Unicode null bytes, that would be a double null byte. That will bypass the check. Just including the \u and 4 zeros is enough to get around the expression filtering.
Coding is hard. So yeah, that allows the stored-XSS, and then so it seems Microsoft really missed on this issue when it came to like triaging and looking at the report. They rated the issue as important spoofing, which they note is one of the lowest ratings that they'll give that's still in scope. So the issues were fixed at the end of October, but they didn't issue any CVEs. And it seems like there was a fundamental disagreement on the impact of these issues for some weird reason. I'm not sure how you'd rate a stored-XSS as spoofing.
So
I
I can explain that a little bit.
Okay.
The cross-site scripting, in order to get RCE, what they do is they take advantage. So there is the RCE that they do would happen even if like node integration was off, if there's isolation, all of that. Because what they do is they take advantage of the team's IPC. So it exposes the safe IPC call, Electron safe IPC, and then you can send different commands. So one of the commands they send is the desktop file download to download any file. And then on success with that, they pull some information and then do another one, which is allow window open URL to open just any website. So they're just abusing the actual team's IPC. So they're basically, what Microsoft is kind of doing here is saying it's not a bug, it's a feature. The aspect of RCE. So at that point, it's just being able to kind of craft these custom spoofed messages and not the RCE aspect. So I think that's where Microsoft's coming down on it. And then they don't file the CVE for it because it's an automatically updated product. It's, you know, hosted by them. So you don't have any other companies that are going to be like hosting the this particular team's server and who need to track the vulnerability. So I can kind of see the argument on that. As a web service, nobody else is running it. Like, nobody needs to track vulnerabilities, which is kind of what CVEs are for.
I was gonna say this kind of opens up an interesting question of what should CVEs be for? Should they be strictly for tracking issues to allow vendors to notify customers or whatever to update, or should they also be like a trophy system for security researchers, which is what they're treated as? Like, let's be honest, CVEs are mostly a trophy system. I think they're used for that more than they're actually used for uh advisories. So in that context, it seems like they kind of got robbed of something. Like, CVEs are good for like putting on like resumes and stuff like that, for example, right? So I could understand why they'd be upset for getting robbed from a CVE, but it seems like Microsoft is kind of taking that stance of CVE shouldn't be trophies, they should strictly be advisories.
I mean,
Um,
that's the intent of CVE, though, is for the defensive side to be able to quickly scan and reference, you know, what vulnerabilities do exist and are known about. And that's definitely how they're used on the blue team. I mean, yeah, sure, on the offensive side, you can kind of use them like a trophy case, as you're saying, but that doesn't negate the fact that they are actually used and like usefully used on the blue side for defensive purposes and doing that sort of scanning.
so do you think the authors here are kind of like blowing it out of proportion a little bit, thinking that
No, I think
you think like
I
Microsoft
think the
is?
problem with Microsoft here is the fact they did rate it as informational, or not information, important in spoofing. There is RCE. I don't really care about the fact that it's only like I did just go and kind of explain how it's through their safe IPC and it's kind of a feature. But that doesn't really change the fact that it's still remote code execution because of the earlier vulnerability. So I do think it's Microsoft downplaying it. I don't think the author's in the wrong here. I mean, they just make the comment about the CV. They don't put much emphasis on the CV aspect. And I think that's fair. I mean, if you want to put on your resume, you can put the write-up on here too. Or even the Microsoft. I think they have well, they did publish something because they gave it the important spoofing rating. So like there is something to reference.
Yeah. Um, yeah, I see what you're saying there. What Microsoft is saying there doesn't, it's not really relevant to the impact of the issue. So it's relevant to the technical details maybe, but not to the impact. So, all right, fair enough. So we have an essay that was published by Ian Beer from Project Zero. And I say essay because this blog post is about 30,200 words. That is not hyperbole. That is a legitimate count. I put it in a word counter. Now that does probably include some like code snippets and stuff, but it's very long. So this post delves into a remotely exploitable heap overflow vulnerability, as well as all the ways that he attempted to exploit it and how he eventually did end up exploiting it. It leads off with a video that some of you might have seen circulating on social media. It's a video of a bunch of iPhones sitting on the ground, and within a couple seconds, they all get crashed due to this exploit. But it's not just a remote denial of service, as the video might imply. He managed to take this to code execution. So he starts off the post with initial research and finding of this vulnerability back when, and how he found it was the iOS kernel symbols were leaked in the iOS 12 beta 1 build. I can't remember. I feel like we did touch on it briefly on the podcast. I don't think we had a long discussion, but I think we might have mentioned it.
No, we've mentioned the fact that we brought it up actually in response to another iOS vulnerability that I think took advantage of it. We've kind of talked about it as a side topic.
Yeah. So Apple had just forgot to strip out the symbols when they shipped the beta build, so that gave a extremely useful tool for researchers because symbols usually aren't public. Um, and he ended up finding a function for parsing ADWL trees. At the time, he didn't know what that stood for, but he now knows it stands for Apple Wireless Direct Link. I guess it would be Apple Direct Wireless Link since it's ADWL. And it's used for networking with other Apple devices like Apple TV and stuff like that. And he found this function took a user-provided size and buffer and did some memory operations on it, such as a mem move. Um, and what was really odd was the fact that it had a bounds check, but the bounds check didn't really seem to do anything when it came to control flow. It prints out a path length error to the log, but then it just continues as usual. It doesn't take any different code flow to, fix fix up the numbers so that they fall in bounds or anything like that. So it's a logic bug that led to heap overflow through the mem move.
Yeah, and I thought this was kind of a really interesting pattern too, just because it shows like somebody recognizes that there is the path length there. So what it's doing there, actually, if you're watching on stream, you can kind of see it doing the if sum u16 equals v6, like basically calculates what the max size is and checks if it's equal to the max size. Seems a little bit weird when he does a bit more reverse engineering on the code and rewrites it a little bit. It does make a little bit more sense what it's doing. Because it does seem a little bit weird how it does like this. If the two values are equal, like if sum u16 equals v6, what does it do if that condition's true? It sets sum u16 equal to v6. Basically does nothing. And then there's the else condition showing the length. But as an interesting pattern, just because it shows there's somebody recognized there's the error. I don't know if maybe they had planned to make that a log fatal and then just kind of forgot and had as debug while they were testing something, or what happened there. But yeah, the fact that it really does nothing after noticing the error is kind of what makes this issue, or basically what happened here is it just carries on.
So I'm gonna go into some very wild speculation here. I could be very wrong, but I'm gonna have some fun with it. I'm gonna say maybe on like a debug builds or something, this did do something useful. Like maybe there's a macro or like something if-def where it did do like a fatal assertion or something if this path was taken, or if that like that log debug function might have something that just got if-def'd out in release builds.
I
I
mean,
could totally see that being the case.
Usually a log debug though, like that's just a debugging level. Usually like the debug just isn't going to do very much. It's one of the lowest levels you can have for that. And thank you, Mr. Gate, for the sub.
7 months. Crazy. Thank you. So yeah, this was actually such a simple bug that he initially didn't think it was real. He notes, typically in my experience, bugs this shallow and real attack surface don't tend to work out, because usually there's a check that's like many levels up, or there's something that's really easy to miss, especially when you're doing black box or like binary vuln research. So he ended up testing it, and it was straight up just a bug that he was able to abuse. Now, even though the bug itself was kind of simple, the exploit was about the furthest thing from simple.
Yeah,
He
and
went through a lot of the strategies he
I
attempted.
do want to comment really quickly that they did also, while it was a fairly straightforward bug, there was a check earlier on that basically made sure it wasn't going beyond 1024. So that did limit how much of an override he was able to get. And I guess since we've only kind of said like to use a mem move. Basically, this size was used in a mem move, so you're getting a heap-based overflow with it. You're able to override into the next blocks.
Yeah. So he went through a lot of the strategies he attempted that didn't really work out after getting more background on ADWL. He was trying to find objects that he could smash with that heap overflow to get useful primitives. After a while, he managed to get a read primitive by smashing the steering message blob, which is used for BSS steering. Though that read primitive he got was really limited. I thought the scenario that he had here was actually really interesting because I'd never seen it before. The size of what was read was actually bound to the data of where you controlled the pointer, because it read the size from the second D word of the pointer you smash. So, in a way, you were kind of restricted on that read. If you read something where there was a really high value as that second D word, you were kind of screwed. You just couldn't read that memory. The reading was also kind of slow, although Z, I think you were saying you could kind of influence it, right? Based on how you exploited it.
Yeah, it could be slow. It depended. He mentioned actually he kind of touched some way and gets into speeding up his exploit that um the technique he started with, it could take like up to 10 seconds to actually get a read.
Yeah. So he did eventually manage to get an arbitrary add primitive as well by smashing a peer manager. So he could increment the value at any address by corrupting a pointer to an object which has a counter for the number of bytes received from peers. And I believe by combining these primitives together, he managed to eventually get arbitrary read write. Now, it's not quite that simple. He had a lot of barriers to work through. For example, I think one issue we had was the write would trigger a panic because of the object being used in other places, and he had to figure out how to work around that. I didn't read through all of the ins and outs because, like I said, this is a very long blog post. It would take me a while to get through all of it. Um, what was also interesting though, there was a few other accidental 0 days that were discovered that were touched on but weren't really talked about in the context of exploitation in this blog post. There was a double free in the same subsystem, which was mentioned earlier this year on Twitter by Mark Dowd in May. Um, Now, the issue and the exploit themselves are certainly interesting, and I think anybody who likes security research should try to give this at least a cursory reading. If not, if you find it more interesting, you can do it like do a full reading. What I found most interesting personally, though, since I don't really do iOS stuff, is some of the background insights that Ian Beer talks about, particularly when it comes to attack versus defense in the exploit space. Um, so, like a few of the quotes he mentions is like the ratio of security engineers to developers might be 1 to 20 or 1 to 40 or even higher. I think people really underestimate how big some of the attacking teams can be in relation to the defending teams. Defense really has like a massive disadvantage when it comes to uh, security. And to tackle this insurmountable challenge, he says security teams might place heavy emphasis on design level reviews, mitigations, as well as fuzzing to try to catch up there.
Yeah, what I kind of took away from this goes in a little bit of a different direction. It's on the exploit strategy aspect. Rather than the background, I did find his analysis of basically just covering his strategy to be somewhat interesting here. And I think it's important to note how much time he did end up spending on this and the dead ends that he did go down, because it's so easy when you look at a lot of write-ups, and I've mentioned this many times, it's so easy to get the idea that they just know everything that they need to do right away. That's just like, oh yeah, I've got this, therefore I'm doing this and this and this, and there's my exploit. And yeah, that is sometimes the case. But it's also the case that's like, you know, these rough ideas, and he covers kind of his 4 options for, I've got an overflow now. You know, here are the kind of 4 ways or 4 approaches that I can exploit, being, you know, overriding another peer, forcing another object to be next to it, coercing it to be at the end of the actual, at the end of a segment. Like, he covers these different options there, or even just exploiting the other fields in the tree that he was overriding. Kind of covers those, and it's like, you know that much, and now it's like, where do you go from there? And that's one of the big differences between when you're learning about exploit dev. Oftentimes you're doing these CTF size challenges where there is only really one strategy or one possible way you can go. And in the real world, you've just got these more complex applications where you can do anything you want, but it might not work out. So kind of just seeing the approach there, I think kind of makes this a really valuable write-up, to see that approach on something that is reasonably hardened, like iOS. It's not an easy target. It's not a straightforward just overwrite, you know, some function pointer. And he actually talks about why some of the issues with overwriting some pointers, talking about pack and some of the options to bypass that. So, I mean, my big takeaway of this one was a lot more related to just that strategy. And I think there's a lot of benefit for people to kind of see all the effort that goes into coming up with an exploit strategy, because, like I said, with CTFs, you usually only have one, but in the real world, you've got to be thinking about everything you've got and how do you start leveraging it to get more.
Touching on that point you mentioned about how long this took him, I believe you mentioned this took 6 months all in all. Research, finding the vulnerability, and exploiting it. And Ian Beers is probably like one of the best people when it comes to exploit development. So that just kind of highlights how difficult of a target iOS really is. Um, Now, I did want to touch back a little bit on some of the insights that he offered, particularly when it came to fuzzing. Um, there's a quote here I think that's like really insightful that people should probably give a read or listen to. And it's fuzzing is often misunderstood as an effective method to discover easy to find vulnerabilities or low hanging fruit. A more precise description would be that fuzzing is an effective method to discover easy to fuzz vulnerabilities. Plenty of vulnerabilities which a skilled researcher would consider low hanging fruit can require researching a program to the point where no fuzzer today would be able to reach it, no matter how many resources are used. I think that is a really interesting distinction and one I hadn't really thought of before. There was definitely a point in time, like especially like 2 years ago, maybe, where I thought the same like opinion that he's criticizing here. Fuzzing will just find low hanging fruit, but there's a lot more nuance to it than that. It's not that cut and dry. And I thought that was kind of an interesting like PSA type quote when it came to fuzzing. So
I mean, I don't think he's wrong about fuzzing finds issues that are easy to find with fuzzing. And as fuzzers advance, like they do find deeper and deeper issues. There has been huge improvement on getting more code coverage, and we've talked before about, how to actually judge a fuzzer and some of the options around that. But he's not wrong in terms of like fuzzing doesn't find all of the low hanging fruit. There are things that a researcher can find, and that's why I always think like fuzzing is augmenting the research. It's not replacing the manual research. It's there to augment some of the work. You run the fuzzer, you do your manual assessment. You don't just run the fuzzer. It's there. It can help. It can show you areas if you're getting a lot of crashes. It gives you an area that you as a researcher can then go look at. It's not there to just replace it, but it does find. I mentioned before the idea of the unreasonable effectiveness of fuzzers to just find a lot of those bugs. But he's not wrong. Like, it only finds a certain type of bug that can be fuzzed. There's definitely lots of logic issues that just don't get picked up.
so there was a final point I wanted to mention on the technical aspect when it came to pack. Uh, this is a good post to demonstrate that pack is not the saving grace, and iOS exploitation is just not possible because of it. For those not familiar with the terminology, pack is pointer authentication codes. So basically, pointers get encrypted in a sense with a tag. And then when those pointers are followed, the tag is checked internally by the CPU. And if it doesn't match, then it will like crash the device or whatever. What this post shows is arbitrary read write is still a very like powerful primitive that is not going to get mitigated by pack, and that's exactly why he just stopped there. You don't need code execution as much as some people might think you need direct code execution, and this post kind of shows that off. Now, while this post is really long, like I mentioned earlier, I think it's very accessible relative to iOS stuff. iOS stuff is really hard to get into. And this post is really accessible and it has a lot of really nice diagrams I found. Some like exploit write-ups you look up, they either don't have diagrams or the diagrams are kind of like really convoluted and hard to follow. I think the diagrams here really offered a lot of value. And I think even if you're not like a, expert exploit developer or whatever, you can still take something away from this blog post.
Yeah, there's a ton of information here. Like I said, I think even one easy takeaway that I think anybody can get from it is that look at the exploit strategy. And frankly, how frustrating it can be at times when you don't know where to go. I will say I did pull it up briefly, but the original report is also, if you're just interested in what the bug was, is a bit more clear and a little bit more, a lot more concise in terms of what the actual issue is. So that'll be in the description for everybody who wants to take a look at that. But if you're just interested in what the bug was and not the exploitation aspect, then I think that's a better place to look.
Somebody's looking for a fun exercise out there to get into some like iOS exploitation or something, take a look at the double free. See if you can exploit that, because that might be more trivial to exploit than this bug was. So it might be like a lower barrier to entry, and it could be a fun write-up you could do. So, on another episode of 2-year-old issues that just got disclosed, we have an integer overflow yielding heap-based buffer overflow in curl. So the set URL function, which is used internally on a user passed URL, allocates a scratch buffer for the path for parsing the URL. And to do this, it has to take the length of it and it multiplies it by 2 and then adds 2 for some weird reason, and then passes that to allocate the buffer into malloc. Um, Now, there's a pretty blatant integer overflow here. If you pass a string that's large enough, that multiplication or bit shift will overflow and wrap around since the malloc takes an unsigned size. Now, when the original length is used for validation, it's broken because the overflow breaks any assumptions made by the code for the buffer length. Um, it wasn't made clear if this could be exploited for more than just a DOS. The impact section of the report notes it might lead to a crash or some other impact. Um, and it's also worth noting this would only be exploitable on 32-bit architectures. 64-bit, malloc takes an unsigned long, and you would need an unreasonable string length to be able to overflow a 64-bit size. That's not a reasonable ask. So I wanted to do some speculation on whether or not we think this could be exploitable, and I'm gonna come down on no. I don't think this could really be used for anything other than a DOS. Um, when it comes to justifications, for one thing, it's a parser issue. ASLR would make this issue probably impossible to exploit without another bug. For two, you need a really long string to trigger the overflow, and you can't control the length beyond just the length of the string. So you'll probably just smash the heap to a state of no repair. And even if you could exploit this for code execution, um, it's not really practical. This seems like more of a self-exploit, unless for some reason you're using curl in an application and allowing users to pass arbitrary URLs to curl.
Which isn't like curl does get used quite a bit. I mean, it's the basis for like a lot of PHP code will use curl. So there's a lot of cases where you might be able to gain control over the URL length. I agree with you that being in the heap, there isn't a really clear direct exploit for it, but you kind of have to look into it a bit more. You have to take the time to actually see what is on the heap, what's there. It can appear to be a self-DOS, but because curl is such a widely used application, like it's definitely could be used in a way that might be exploitable. But yeah, they don't cover any sort of exploit. Like this is just made as a report to the bug bounty. And they got a $150 bounty from it. Just reporting, you know, hey, there's this heap overflow there. Actually exploiting it would be more difficult. Like I say, it is I've at the parser level, which also creates some difficulty. It would be difficult to exploit. I don't know. I wouldn't be willing to say like it's not exploitable without having more time to look at how curl works and what's actually sitting on the heap.
Let's say for the sake of argument though, you had to pick one. You couldn't say I want more time to look. You had to say yes or no. Would you come down on no? Or more likely to be no?
It's a good question. I just don't know what to say because I don't know what information you might be able to abuse that's on the heap. Although I guess probably no, given the 2 GB read that it's going to have to do. The odds if
Exactly.
it's smashing.
That's what I think is a killer. I think that would kill any exploitability. You are doing such a huge smashing of the heap. You're going to smash so many things along the way. And you might even, like, how big is heap actually on 32-bit?
Well, I mean, that it varies depending on how much room you actually need. So it is calling malloc, so it should get the space given to it.
I'm just thinking you might even just run into unmapped memory and just you would be guaranteed a crash, in which case this would absolutely not be exploitable. But
yeah, well,
I'm
that's
not
I guess
totally
one thing.
certain
I
on
guess
that angle.
when I say it should be given the memory, like in this exploit, because you're going to be calling it, what is it? Like you get the int overflow there, so you can get it to call with something smaller, I think. And then write larger.
You would have to find a way to terminate that write probably, which might be like hard or impossible. But
Yeah, that's going to depend on some of the internals.
It's fun to think about. I don't think we can, like you said though, we can't come down hard on no because we don't have all the technical details and all the internal state information. But I would probably lean to no.
We can come down saying, lean no.
Yeah.
Um, it's always true though. Like, there's always the chance that somebody just is going to be a little bit more creative in how they take advantage of it and find something. And out of chat, Mr. Gabe mentions, old parsers are a good attack vector, and they are, like, especially when you're starting to learn stuff. Like, there are a lot of parser bugs, but with ASLR now in place on most systems and dep, you're kind of limited when it comes to those parser bugs. They do become a lot harder to exploit, but when you're learning, they're great. So you don't have to deal with like ASLR. You can do quite a bit with them, and they're usually fun and straightforward.
So it gets kind of weird when we look at the meta of this report, because usually you'll see if an issue is like 2 years old or whatever it gets disclosed. It's at the request of the researcher, and the vendor drags their heels or whatever. In this case, it was at the request of the curl staff member. Um, 2 years later, the curl staff member just decided, oh, let's make this report public. Like it seems weird to me.
Yeah, I thought it was weird, and there were actually two other curl issues that got disclosed around the same time. And I went and looked at them, and they were not 2 years old. So it wasn't like they just suddenly like, oh, well, let's get rid of the backlog. So I'm not sure why. I did think this one was a little bit weird too. We can't really speculate on why, because yeah, this was even paid out 2 years ago. I did find that kind of interesting, but we have no way to really know why that was.
It's possible they just noticed that it was missed while they were publishing other ones, and they were like, "Oh, let's just throw this one in too." It's
Perhaps, yeah.
probably more boring than what we're thinking.
Yeah, I mean, well, I don't think there's like some dramatic story about like this
No.
internal war waged within curl or the internet bug bounty about whether or not to disclose this issue.
Mr. Gate in chat said maybe the person contacted them or requested disclosure. Oh, by email, not maybe. But at that point, you might as well just use the HackerOne report you already have that communication channel with. Like, normally you don't vary up your communication channel if you already have one established.
Yeah, like asking for the disclosure is built right into HackerOne. So it would seem weird if they went. It is possible. It's possible they sent snail mail too, but I'm not sure how likely that is. I mean, it's possible.
Yeah, look at that there. So our last exploit is Google Duo, race condition causing a callee to leak video packets from an unanswered call. So Z, I'll let you take this one over because I think you have a better grasp on this one than I do.
Yeah, so this one was just a race condition. All that happens is when you have that WebRTC call started, ideally it shouldn't be sending any sort of video packets or anything until you've actually accepted that call. But the way it does this is kind of the connection starts, it sets the locale description, and then it once that's happened in the success handler, it'll disable all of your video codecs, I believe. Basically, it disables all of the outgoing traffic, so you can't send any videos. But normally that happens really quickly. It's you set the one value, and really quickly it gets into the success handler and runs the disablement, the code that disables it. However, because it happens in that response in the onset success handler, if you could delay that from running, so if you could delay it by having a lot of spam messages coming through, because it's happening on a separate thread, you can basically delay the disabling of outgoing traffic long enough to actually start getting some video being sent out, despite the fact that the call hasn't actually been answered yet, which is essentially where the race condition comes from. You're able to slow that down, you're able to get more information sent out.
I feel like I've seen an issue like this that was kind of similar from like a year or two back.
Yeah, well, I think we covered WhatsApp.
I was gonna say I feel like it was a Facebook thing or like a Facebook application.
Yeah, I thought it was a WhatsApp that we had another similar sort of. I don't think it was a race condition like this one exactly. but it was that same issue where it was sending things before you actually answered the call.
If I remember correctly, the reason that one really blew up was it was actually being exploited in the wild. This one, I don't think they say anything to that effect. I don't think they have any evidence this was being exploited. Because if it was, I think it would have been subject to the 7-day disclosure, not the 90-day. But yeah, I mean, this really like set bells off in my head, like remembering that WhatsApp issue, which
Yeah, definitely
I didn't
very
have when I
familiar.
initially read it. Yeah. All right, so we'll move into research. So we have a blog post from Alexander Popov about a Linux kernel heap quarantining technique he POC'd, especially with the world how it is right now. You'd think I'd be able to pronounce quarantine. In an effort to mitigate use after freeze in the Linux kernel. So basically, how this works is when an object gets freed, it doesn't get immediately released into the queue to be reallocated. Instead, it's put in a quarantine, and then the freed addresses in that quarantine aren't released until it reaches a size that's too large, and then it releases them all. Um, Now, that does raise the question, what if an attacker just floods the quarantine to get the pointer released to spray it? And while that's not fully mitigated, this solution does include another strategy, which is combining the init on free capability to zero memory when it enters the quarantine. So while this strategy could certainly be countered, and actually is by Jan Horn in here, it could still hold value as a mitigation if the performance is good. Spoiler, it's not. Um,
So I
because
will also mention that he does actually take a little bit more step there by randomizing when things can get released. So he batches everything that goes into the quarantine, and then once the things get too large or when it's going to scale back the quarantine, it'll release half of an entire batch at random. So that means you can have some that kind of sits in there for a very long time, and isn't consistently able to be released from quarantine. Because its first example here, it's always coming out after like 182,000 requests or like objects going through. And one key thing with this is you do kind of need the allocations and the freeze in order to push things through the quarantine. If you're just able to free things, um, or if you're just able to allocate, it never ends up pushing anything out of quarantine. It just keeps allocating more new content. So you do kind of need to be able to do both actions. And you kind of need to have an infinite spray of sorts in order to actually get anything through. If you have an infinite spray and infinite time, you're still able to kind of get something through the quarantine. But it's worth knowing, like, because of the randomness also, it's hard to know when you can stop. He mentions here in one case, the target object, even after 400,000 attempts, never got reallocated. But then there are other cases where it came out after like 87,000. So, like, say you've randomized it to try and make it more difficult to know when it's actually going to come out. And then he got into the actual erasing them using the init on free.
so while this strategy could be countered, um, I think where it could offer value is it would make race-based UAFs hard to exploit. Anything where there's like a time-sensitive nature, this is going to really kind of screw you there. And it makes UAF where you're dependent on the stale data impossible to exploit, though that's mostly due to the init on free and less because of the heap quarantining. But still, if you need any of that data intact, you're not gonna get that with this mitigation in place. That being said, you may remember earlier I said this could hold value as a mitigation if the performance is good, and I said spoiler alert, it's not. The network throughput testing showed 30% less throughput. 28% of that was init on free being responsible, 2% from the quarantine. And the scheduler stress test showed a slowdown of up to 97%. 5.3 being from init on free and almost 92% being from the quarantine. So there are some massive performance penalties here. Um, he does note that this is not optimized code, it's research code. That being said, performance impacts that are that large, I mean, I don't know if there's any amount of optimizations you can do in the world to really make that viable. Um,
Yeah,
it
I mean,
was
a
a
lot
cool
of that
experiment, though.
impact, I think also just came down like the init on free, because init on free has a very significant um performance impact. That's why it's not used by default. Um, the whole thing, though, one thing that is worth noting is Jan Horn basically reviewed this, and from a security perspective, reviewed it, and pointed out one of the observations being that the quarantine is shared on like the CPU level, which means that somebody could sleep their main attack thread, go on another thread and do all the allocations and deallocations from, even if it's another size, because the kernel heap is split up into different sized blocks. But you can sleep on another one and open up another thread that's just going to do all those allocations to push things through the quarantine, go back to your original one, and almost immediately get the object to be allocated. So he basically bypassed it altogether by separating that. As long as an attacker, you'd have access on when the use after free happens, like when the second use happens and when the free happens. You'd be able to exploit it that way by just sleeping for a bit and pushing things through the quarantine somewhere else.
Yeah.
Which limits the usability of this as an actual mitigation.
For sure. So, like you said, for those reasons plus the performance reasons, unfortunately, this doesn't really work out. Though I did kind of like the idea, and it was a cool experiment. Even in the conclusion, he acknowledges that this is not suitable for mainline. Um, there are some suggestions from other people who do Linux kernel work, like Jan Horn and Keys Cook, mainly stating that the best way to prevent UAF would be to give objects dedicated caches so that you can't overlap objects of different types. Um, that is like that would legitimately almost kill UAFs as a bug class, but it's not really practical to do because I mean, how many different types of objects do you have in the Linux kernel? What are you going to
Yeah,
do?
so
Create 300,000 caches? Like,
well, so
no.
they talk about doing it at the compiler level, having the compiler be knowledgeable about that, rather than it being done at like just the code level and knowing the types, which is an interesting idea. I'm not sure how well it would work out, but it's definitely a possibility.
I don't think we'll see
That's
it anytime soon.
no,
Um,
no, I don't think so either. But it is an interesting suggestion on a mitigation that would be quite impactful. Very likely though, because that's going to kill any sort of caching and like any cache hits. Like it'll have a significant impact on performance. Almost certainly.
and for those not like super familiar with Linus, he absolutely hates things that bombard and kill performance for security reasons. He hates it. That's like one of his like biggest triggers. So don't expect it to go through at least to mainline. Um, I feel like we've seen white papers that have kind of touched on that angle before of setting up those types of caches, and it just never really went to fruition because I think the performance hit was just too great. Um, but yeah, it was still a cool experiment, and I like the approach, even though it didn't really work out. So our final research topic of the day is Alexa. Um, it's about using voice assistants like Alexa to decode smartphone sounds. So this definitely isn't the first time we've covered a paper that's used voice assistants and IoT and stuff like that, and how they can be misused as side channels for getting information. Mainly, what they focus on in this paper is using the microphones on the assistant devices like Alexa to record and identify virtual keyboard taps. So this can compromise sensitive things, obviously, like passwords, pins, text messages, stuff like that. I believe the way this works is it uses an array of microphones to determine the direction of arrival of the sound. And then they use that combined with linear discriminant analysis or CNNs. I think they found LDA had better accuracy though. They
Yes,
could
they did.
basically estimate which keys were being tapped without needing to hijack the microphone on the device. Because some of the attacks that have happened before with side channeling what a user was doing on the device involved hijacking the microphone that was directly on the device to pick up the vibrations, which is a more accurate attack than this. But this
Yeah, I
allows
think
you
we
to
even
do it without
covered
using
that
the
during one
direct
episode.
microphone. I think we did too. I think it was a really early one. Because I don't think we talked. It's definitely been like a year or something since that we covered that. I think.
Yeah, it's
So
been a while. I don't recall what episode. I do remember talking about that internal mic one. Um, the performance here, so it is also worth noting that this is within half a meter of the smart device and kind of takes advantage of the fact that these smart devices will automatically start recording, usually after they hear some sort of keyword, and that ends up being sent over to like Google will store it or Amazon will store that, and you can kind of review everything it's recorded from you, which the fact that it's stored and kind of associated with the user account, like if somebody gains access to all of your sort stuff, they might be able to find a case where you're inputting the code while it's accidentally recording. Presumably, if you're using it, you're not also in the middle of entering like your PIN. So it'd probably be accidental. They bring up the threat model of the fact that that information or those recordings are shared for like training purposes and stuff, for people to actually write the, or for people to label it. That shouldn't be shared with knowledge of your user account, though, which makes it kind of hard to actually exploit that issue, even if they were able to figure out your PIN from the recording. And then when it's stored, that's a fair attack surface. I don't know, this does feel like it's interesting to know that these devices could record and you can determine with a degree of accuracy what pins were actually or what values were actually used. That said, it has to be within half a meter, which is pretty close to the device. It's not like just a device in the same room can pick up your taps. You have to be pretty close. They don't really talk about, or maybe they do and I missed it, about how silent the rooms are, but I presume they were keeping their rooms pretty silent. There wasn't any sort of background noise or much background noise. And they got about 25 to 34% accuracy of a 4-digit pin with 20 guesses. So they weren't accurate right off the bat. And if you only go with like the 10 guesses, the highest percentage they got to was the 26%. So it's not getting a lot of the pins too quickly. So just having the recording, you're not getting too far with this. It is, like I said, it's interesting. That's why I brought it up, because it is interesting to know, like, you can do this sort of analysis. But the practicality of this is definitely limited in terms of the results they're showing. But this is just a first attempt at it. You know, somebody with more money to do more training on either the CNN to put more resources into that might be able to do more. But it does feel like you're always going to be fairly limited, being a remote microphone, being a very a silent tap. You're able to get some information, both the relative position of the taps, but you're still pretty limited, especially when they need multiple guesses to actually get the values. That means you're not just going to be able to work from the record and be like, I know your pin, so I can do a really quick attack. Trying like 20 pins is going to take a bit of effort. Most of these phones are also going to be limiting you to, you know, maybe 5, and then you have to wait however long before you can actually make further attempts.
the accuracy problem comes down to the fact that there's a lower signal to noise ratio, and it gets even lower the further away your target gets. So you might be able to pull off this attack a meter away, but it's just your accuracy takes a massive hit, and you would need a lot more guesses. What I found interesting though was the accuracy was somewhat reasonable when it came to text reconstruction. They found that text could be reconstructed with a 50% accuracy. I think the reason for that is with text, you can do further analysis to try to fix it up by using like frequency analysis, like letter distribution, dictionaries for like correcting spelling errors and stuff like that.
Yeah, and
Um,
they made use of the dictionary attacks during this. And yeah, they can leak some information off that, but again, this threat model is dependent on the accidental recording, which means they're also not going to be that long of a recording. I think they don't
yeah,
usually record for all that long, so a
I
few
think it's for a few
words, not
seconds.
sentences.
Yeah. It's funny though, in this specific case, it's almost like pins are stronger than passwords against this specific type of attack.
Oh no,
Um,
there's research about the sound depends. That's old already.
oh, okay. Well, to me, it's new, so whatever.
Yeah, no,
Um,
that's definitely something that's been looked at. I mean, we haven't covered any of those papers, but the sound of writing is something that can be analyzed also to do this sort of attack with and figure out what somebody is writing.
There were some other like little interesting things that I found. They're not really like relevant to the practicality or anything. Well, actually, this one kind of is. They found that their attack worked better if if the phone or whatever. I think they use an iPhone. Um, if it's in landscape orientation instead of portrait, and the reasoning for that being, when you're in landscape, the keys are further apart, right, and they're bigger than they are in portrait, where they're more like tightly clustered together. That was kind of an interesting observation that it highlights how sensitive this attack is. That something as trivial as that, like most people who are using their device wouldn't even think about the orientation they're using, and they're probably using portrait anyway. But it's just funny that something as trivial as that is makes an impact on this type of attack, and that's just the nature of how sensitive it is. But yeah, it's not really a super practical attack, but
No, but
it's
definitely
fun to cover.
interesting, like the fact that it could be done. Like I know I've seen papers about, so I remember seeing the internal microphone, but also just about typing. And I mean, that's where you have these tactile keys that make a very distinctive sound, and you can kind of train on that. Whereas the touch screen feels like something that it should be a lot harder to get information from, just from the sound of the touch. So I did find that aspect interesting too.
One thing with keyboards, though, you would have to normalize for the types of switches too, because like I, for example, have a green switch keyboard. You could probably hear it from like the house next to me. But if you can get like quiet switches too. So it would be interesting to see how you would tackle that actually between the different types of switches that are used by keyboards
Well, you can
for
still
the
do that
noise.
analysis on like distance and distance between the different keys that are being typed, rather than just on this one key is exactly this.
Yeah, you just have to have like a different profile for picking up the key presses.
Yeah.
But yeah, that was kind of a fun thing I was thinking of when you brought that up. Um, I will move into shoutouts in a second. I just wanted to pull something out of chat. People talking about PS4 and the Black Hat talk. I believe the Black Hat talk for the PS4 WebKit issue is on the 10th. That being said, as far as I'm aware, Black Hat is a paid conference. It's not like this talk is just going to be streamed for free. I don't think. So there's a lot of people that are hyped about it. Uh, I think they don't realize that the pass for Black Hat, I think the pass is like £430 or something. It is not cheap. So unless you have a pass or you know somebody that has a pass, you probably won't be getting that information until like months down the line when they release the talks on like YouTube or whatever. I'm not 100% confident on that, but I believe that, people who are expecting to see public information on the 10th might be disappointed. Don't get too hyped up for it. Because it's possible that that information is not immediately public. So, all right. With that said, we'll move into some shoutouts. So, XS Leaks Wiki, Google. I think this is an update, right? This wiki's been around, but I think they just did like a massive update for it. Am I correct on that?
As far as I'm aware, it's new. I've never, I
That's
didn't
what I
know
thought
about
at
before.
first.
It sounded like I'll see if I can pull up the actual Google post. But it seemed like it was something that they just launched. I'm just trying to find the post from Google here. I'm bringing it up now. Yeah, they say here to promote better understanding of these issues and protect the web from them, today marks the launch of XS Leaks Wiki, an open knowledge base which the security community is invited to participate and where researchers can share information about new attacks and defenses.
Okay, yeah, so it was launched. For some reason, I thought that it was like existed, but it was updated. But I can't find where the quote was that made me think that. So, oh well.
Yeah, either
So
way,
yeah,
it's
okay, it was a launch.
yeah, it's an interesting looking wiki. So we've talked a little bit about cross-site leaks before. I think a lot of what we've talked about has been more related to cross-site search vulnerabilities. But this kind of just classifies a bit larger as cross-site leaks. So when we've talked about things like information being exposed over that post message, those post message broadcasts, that's something they're including as a cross-site leak. So they're basically defining this category of types of attacks and covering information about how you can exploit. Out of chat, it's asking, aren't XS leaks dead with the Chrome same site per default? Some of them are. Things like this post message broadcast, I believe, would still be exploitable, but they do actually include on some of the pages where relevant the defenses and what defenses actually protect. So like I just brought up the ID attribute, so that's like I want to say similar to like the DOM clobbering idea where you create an element. Or no, they do something different with this one. So they leak information using the ID attribute. So you create an iframe targeting some ID, and then if you have a object with focus on your own page, when you create that iframe, load the iframe, you can determine if that iframe has an object on there with that ID, because you'll lose focus from your field onto the iframe. Anyway, it does talk about how some things do defend against it, but not everything is defended. A lot of them are going to be with the same site cookies protecting them, but not every issue. And they cover a lot more than just something more traditional. Like I said, the cross-site search, I think, is the one that I always think of, which they cover in here. But they cover some other issues. Definitely interesting. Some things I didn't know about. So, I mean, yeah, interesting wiki that they've launched. I look forward to kind of seeing what comes out there and want to give it that shout out.
Yeah, I think this could be really useful as a quick reference. I especially like the table that's included at the bottom for the defense, and exactly like it's a very like quick and clear indication of what it does and doesn't defend against, and that can be very useful for those quick references.
Yeah, and they include a bit or a good amount also about the defense mechanisms too. It's not just the attacks.
Yeah. What's worth noting here too is they are looking for contributions. So if you see something or you've seen something in your work or whatever that you don't see listed in here and you want to add it, they have contribution guidelines. Basically, you just have to open a pull request to the wiki repository. So yeah, you can contribute to it if you want to. Um, Z, I know you had a shout out as well about Hacking 101 by No Starch Press.
Yeah, well, I just want to call it the fact there's a humble bundle going on right now. There we go. From No Starch Press, who is one of my favorite kind of security publishers. I mean, they have other books too, but you've got some of the classics in there like Hacking Art of Exploitation, which I'm now, thanks to Spectre, are trying hard not to recommend too often anymore, but it is in there for $1.31 Canadian, or I assume that's $1 US. There's a lot of good books in here though. Like last year, I said I was a little bit disappointed by the Humble Bundle, which I want to say was packed. Did that bundle. No Starch always has really good books. Hacking Art of Exploitation, even though I don't go out of my way to recommend it anymore because there are free online resources, it's still probably the best book that introduces you to the exploit development. Really basic exploit development, but still kind of the best introduction in book form. Practical malware analysis, kind of some dynamic reverse engineering stuff in there. A lot of good tips out of it. It's pretty old. Age is definitely showing by this point. But still, it's looking at that dynamic analysis. It's not a bad book. James Forshaw has a book in here called Attacking Network Protocols. Really dense book. A lot of good information out of it. Basically looking at network analysis from a security perspective. As far as I know, it's the only book that's really doing that. A lot of network books are kind of covering more of the forensics aspect of it. And of course, I mean, James Forshaw is definitely well known on that, or in the security industry. Practical Binary Analysis is a book I've been referring to lately as I've been doing a bit more, or trying to build out some of my own tools to do the analysis. Serious Cryptography. I wish I had this book when I was getting started with both just consulting and dealing with some of the crypto issues. Yeah, basically a lot of really good books out of this. And then at the end there, all of the books in the last tier where you have to pay about $20 or whatever US. I'm not sure what the exact, it's 23.65 Canadian. They're all new, so there haven't been bundles with these books as far as I'm aware. So that includes Black Hat Go, which I was super disappointed with. but I was looking forward to it for quite a while. Rootkits and Bootkits I've heard good about. I haven't read it. And I've actually reviewed real world bug hunting on a previous episode. I don't expect if there are any books out of this that kind of stand out to you.
Well, I did have a bit of a question. I don't remember you mentioning to me why you were disappointed about Black Hat Go, because I remember you being excited for it, but I don't remember. Maybe I just have bad memory. Why were you disappointed with Black Hat Go?
As a book, I was just kind of disappointed with the contents of it. Like, it's not the worst book ever. It's just, I don't know. I'll pull up the table of contents here. You've got some TCP stuff, doing HTTP clients with it. A little bit of packet processing. I don't know. None of the topics really excite me. Like, or even felt all that interesting compared with like Black Hat Python. I mean, if you're wanting to learn Go and you want to have some more security centric projects to play around with, like, sure, it's not like it's not worthwhile. I don't know. I just maybe it was built up for a while and I was just ultimately disappointed, but
You just expected more, I guess.
I just kind of expected something different, I guess. It's like I said, it's not that it's bad. Bit more on the pen testing side, but so was Black Hat Python, so I couldn't expect it to be exploit dev, but yeah, I don't know, it has a different feel to me than Black Hat Python, which is what I was kind of comparing it with.
So regarding your question, I don't really have any recommendations that I can think of at the moment in the book list. That said, there are some books in here that I would be interested to check out. The Hardware Hacker, for one. I've been building an interest in hardware hacking. I think it's a really interesting field. Um, that could kind of be like a fun hobby to look at on the side to kind of take the distraction, or to distract away a little bit from some the software exploit development that I do or look at like daily or whatever. The other one I think might be useful is the Real World Bug Hunting Field Guide to Web Hacking. That could be an interesting book for people who are looking into web stuff. And like you said, the books in the $20 tier are newer. But
Yeah,
overall,
and I
when you look at
reviewed the real world bug hunting back on episode 22. I just had to pull that up. But ultimately, I think it's a great reference book. I wouldn't go to it to learn a lot of the techniques, but it is great source to kind of see real bug bounty reports of issues. And maybe get a little bit of inspiration just browsing through it, or see how somebody dealt with something in the real world, not just CTF-ish.
overall though, Humble Bundle is a really awesome program, and we'll pretty much always bring them up when they have like security related bundles, because it's a good deal, it's good cause. The money goes to charity, and there's even sliders that you can denote how much you want to go to whatever charities they're running for that launch. So yeah, I really like Humble Bundle, so I like bringing them up.
Yeah,
I do
they've
have.
always got, like, I mean, as you said, money goes to charity, so uh I'm always happy to buy some of them, even when I own most of the books in it already.
Yeah. I do have a last minute shout out ad. This one even comes as a surprise to see because I forgot to bring it up before we started. It's nothing uh super technical at the moment, but it will be. Gamozo Labs, some of you might have heard of him. We've talked about him in the context of fuzzing before. He is going to be working on an operating system which is targeted specifically for fuzzing. So it has like optimized memory management and scalability and stuff like that in mind, and he's going to be doing live streams. I think he's starting the streams. Yeah, he said streaming will start sometime on Thursday, December 10th, and they will be relatively random. So there's not like a scheduled stream, but he's going to be doing streams of working on this operating system, and I think some of the people who watch us will find that interesting, and might want to have an opportunity to look at that. This was just posted yesterday, so that's why it's kind of a last minute ad. But yeah, I mean, keep a lookout on it. It's OS dev in general is interesting, and fuzzing is interesting. Combining them together, I think, could be really fun. So yeah, keep a lookout for it.
Yeah, and his streams are also just very good. Always kind of fuzzing focused, a lot of development or developing fuzzers. Really good content out of his streams too.
Yeah. With that said, we'll wrap it up here. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube at 6 p.m. Eastern, 3 p.m. Pacific on Tuesday after the stream. We also have previous podcasts up on Spotify, Apple Podcast, and more links on Anchor. If you want to join our community, you can join our Discord. The link is in chat or in the description of the video. Follow us on Twitter for newest updates. Um, Once again, we will be going on break in after next week. So next week will be our last episode for 2 weeks, and then we come back on the 4th of January. But yeah, with that said, we'll be back again next Monday for our final episode before the break, 3 p.m. Eastern, 12 p.m. Pacific. We'll see you all then.